to our lesson today. In this lesson, we are going to investigate the chemical properties of chlorine gas. And first of all, we begin from preparation before we move on to our investigation. So to prepare chlorine, we will prepare chlorine by reacting to our lesson today. In our lesson today, we will discuss preparation of chlorine and investigate the chemical properties of chlorine. To prepare chlorine, we will react a hydrochloric acid, concentrated hydrochloric acid, and manganese oxide in the presence of heat. As you can see in our setup here, we will react chlorine, we will prepare chlorine in a round bottom flask because it is this flask will withstand the heat that we'll be using, and it will also distribute the heat evenly. We will introduce hydrochloric acid using this dropping funnel into the reaction flask. We will pass the gas that we have. As you can see, chlorine is prepared by oxidation of hydrochloric acid in the presence of manganese oxide, and the mixture is heated. So the chlorine being prepared will be passed through distilled water to remove any acid that is boiling, and then we will collect our chlorine inside by downward delivery. We are collecting chlorine by downward delivery because chlorine is denser than air. So we have collected our chlorine and we will test. Our first property is the acidic property of chlorine. And for us to carry out that experiment, the acidic property of chlorine, I have the two litmus. One is red, and I will moist them. The chlorine gas can only show the property if you're using a moist litmus. So I'll place my litmus in the jar of chlorine. Being more reactive than bromine and iodine, it is able to displace the iodide and the bromide ion from their solution. So when chlorine is bubbled through potassium iodide, for example, it will change this solution from colorless to brown, as you will see here. So we are passing chlorine through potassium iodide, and you can see the solution changes from colorless to brown. This shows that chlorine is more reactive than iodine, and therefore it has displaced it from its aqueous solution.